the analytical geometry or XY geometry is basically just geometry on the Cartesian plane. So if we have the Cartesian plane, we have the x-axis and we have the y-axis. And on this Cartesian plane or this grid, we have a series of points. So we might say that that point is the point 2, 2, and we often give it the label of like an A or something like that. Then we might say like a point over here is, let's say, 3, 4, 5, 6, 7, 8. So it's 8. And how high is it? 1, 2, 3, 4, 5. So we'll call that 8, 5, and we'll make that B. And then maybe we could even have a C down here somewhere. And this would be 1, 2, 3, 4, 5, 6, 7, 8. So 8 across, and that would be 2 up. And we'll call that point C. Now, these points can obviously be connected up to form shapes. So this would be a shape. In fact, it would be a triangle, or we'd say that is the triangle ABC. So really, this section is about doing geometry using algebraic ideas and notation. And the way we get that is by using the grid. And the grid, these XY relationships help us do that. So just to get started today, I want to just make sure we're all comfortable with points on the Cartesian plane. So let's have a little multiple choice voting question. Which coordinate pair goes with the letter A over here? Which coordinate pair goes with the letter A over there? Okay, so let's see. We go 1, 2, 3, 4. 1, 2. So we went 4 across and 2 up. And so we would say that the coordinate should be 4, 2, and B. Okay, so that's just, can you identify coordinates in the Cartesian plane? And, I think you guys are pretty comfortable, but it's a basic idea that we have to be comfortable with in this topic. Let's do another one. Let's say, what one goes with the coordinate C over here? Is it A, B, C, or D? So there's a coordinate C, and you need to match it to one of the multiple choice things here. And I want you to put your answer in the chat. Okay, let me have a look. So I like sometimes to draw straight lines up. So we can see the X part is in line with -2. And the Y part is in line with -3. Is there a coordinate -2, -3? Oh, yes, it's this one over here. So it would be A. Awesome. Okay, now when we talk about the Cartesian plane, we talk about quadrants on the Cartesian plane. And you will remember this from trig, I think, previously. But I will just do a little drawing to assist you. So when we talk about the Cartesian plane, we talk about this being quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In which quadrant do you find the point -3, 4? And you can just tell me by voting with A, B, C, or D. Where is the point -3, 4? Which quadrant will it fall into? So you always start at the origin. And in -3, there we go. Okay. There we go. So what we have is we go 1, 2, 3 across, and then we go 1, 2, 3, 4 up. So that would be for me the point -3, 4. Now, what quadrant is that in? It seems to be in the second quadrant. Well, it doesn't seem to be. It is in the second quadrant. Now, I like this question, so I want to give you another one. So I'm going to change this. I'm going to say, what quadrant is the point -3.5 in? And you could just vote like using the same things. So what quadrant is the coordinate -3.5 in? So 1, 2, 3, and then a half will just go up a little bit. So the point would be here, but it actually has to also be in the second quadrant. Okay, so second quadrant for that one. Let's do one more because I do like these questions. Let's go with -3, -2. What quadrant will -3, -2 be in? And you can just use the voting thing again. So if I go 1, 2, oh wait, I'm going in the wrong direction. Goodness gracious. -3, 1, 2, 3. And then I go 1, 2. I seem to end up over here, which is the third quadrant. Okay, now this is going to be very important. You need to be able to get into the right quadrants when you do these, and you also need to do little sketch drawings. So these skills are fundamental to all of this. Okay, dokie. Now, the first skill that we need to learn about today to really get going is something called the distance formula. So let us look at a question. No, let me even make up a question here just to get us going. So what the distance formula does is it allows us to measure the distance between any 2 points on the Cartesian plane. So let's go with this point over here. I'm going to call it A. And then let me go with this point over here. We're going to call it B. And if I count with the blocks, this is the point 1, 1. And this would be the point 2, 3. So it's 4. So 4. And then this would be 1, 2, 3, 4, 5. So what we need to develop, and what I'm going to show you now, is a tool that measures the distance between 2 points on the Cartesian plane. And in this section, what we would call the distance between 2 points, the notation we would use would just be not an M, it would be a D. What is the distance between A and B? But to help us, we're going to use a friend from the past. So if I had to say to you, how long in blocks is the blue line and how long in blocks is the green line, could you tell me, like just by looking at the blocks? How long is the blue block and how long is the green block? Yeah, so the green block is 3 and the green block is 4. The blue block is 3, the green block is 4. Now, this is ringing a few memory bells. What is this drawing reminding us of? Is it ringing any bells for you? It's a right angle triangle, yes. And what do you know about right angle triangles and the relationships between the sides? Can you remember anything that's quite useful? Pythagoras, exactly. So if you had to use your knowledge of Pythagoras, how big do you think this would be? I suppose we can do it. So let's go. Doesn't Pythagoras say 3 squared plus 4 squared should equal to what? I guess AB squared. Give me a thumbs up if you recognize that from Pythagoras, from like grade 9 and 10. Okay, well, what do we think the length of AB is then? What do we think the length of AB is going to be? I guess we have to square root both sides if we want AB. So what are we going to get for my length for AB? Well, 3 squared is 9, 4 squared is 16. The square root of, well, what's 9 plus 16 is 25. So this is 5. Oh, but that makes sense because there's a Pythagorean triple. And so we know that this distance between A, B is 5. All right. Now, here's the thing. We can adapt Pythagoras' theorem to be a general purpose tool, to not just have it work for 2 sets of points and do it like this. We can build our own custom formula. And the way this custom formula is going to work is as follows. So take a screenshot if you want of the working out, but I'm going to show you how the distance formula actually works. So if you want to find the distance between 2 points, what you need is you need 2 squared brackets. These roughly correspond to the change in x. Well, they're actually not roughly, they exactly correspond. And the change in y. Okay? But then to get the distance itself, we also need a square root over this. And this comes from the theorem of Pythagoras. Now, what is the exciting bit inside here? In order to get the change in x, all we do is we go x2 minus x1. And over here, we will go y2 minus y1. Now, these correspond to the change in y on the drawing, and this corresponds to the change in x. Let me show you how much quicker this formula could have handled that original problem. So let's say we have our points, and our points are the point 1, 1, which was A, and the B was the point 4, 5. In order to use the distance formula to find the distance between A and B, I have this squared plus this squared, and then inside it, I'm going to go 4 minus 1. So 4 minus 1. Or I could have just written 3. And I suppose I should have stayed with, maybe I should have stayed with, let's go with, screw it. 4 minus 1. And then here, we're going to say 5 minus 1. But remember, the formula has to have the square root. And then if you think about it, this is just going to be 3 squared, which is 9. That's 4 squared, which is 16. And we get exactly the same answer, which is 5. But now we have a general purpose formula that we can use. So what I want to do now is actually apply this formula, but just give me a thumbs up or a score out of 10 about how you're feeling about using this distance formula. We have to put it into place. We have to use it now. But I just wanted to give you a feel for how the distance formula is really just Pythagoras applied to this Cartesian plane. All right, let's do this question together to get us in the mood for distance formula questions. So you need to find me the distance between these 2 points. And one of these 4 options is correct. I will give you the distance formula above to help you navigate this new problem that you have to deal with. And then I want you guys to tell me which option you think is correct. We're not going to do a drawing here. We can just use our common sense. So over to you guys. So let's have a look here. So I can go 4 minus minus 2. So I'm going to watch out because we've got minus and a minus. Interesting things can happen. And so 4 minus minus 2, and then minus 3 minus 5, which will give us 6 squared plus minus 8 squared, which would give us 36 plus 64, which would give us the square root of 100. So which option do we think it's going to be? It is going to be A, the length 10. Now that's kind of cool. So any 2 points on the Cartesian plane, if you want the distance between them, you can just use this jazzed up Pythagoras theorem, which is called the distance formula, and you're good to go. So that is awesome. Let's do another one. So let's do, I want you, forget about forget about the question for now. All I want you to do to start with is find me the distance between these 2 points, which are basically the opposite ends of the diameter of a circle. So forget about the actual question for now. You don't need to do this part. I just want you to figure out what is the distance between the 2 points in yellow, and then I want you to tell me in the chat. So we're looking for the distance. What are you guys getting for your distance? Well, in this case, it's the diameter as well, but what are you getting for your distance? I mean, you can pop it in your calculator and you will get 17. Yeah, Silicane, Ronnie, I agree, and we all agree. Now, just to kind of go back to the actual question, it didn't ask us for the diameter, it asked us for the radius. So what you just worked out was there were 2 points that were on the end of, basically you figured out what the distance is between those 2 points, and you've got the length 17. I want to know, and the question wants to know, what is the radius of the circle? What is the radius of the circle? Which option here would be the radius of the circle? A, B, C, or D? So if we go back to the last section, we know that there are 2 radiuses in the diameter. And so the radius must just be 17 over 2 or 8.5 in decimal language. And so we would get 8.5, or C. Okay, this is a good point to stop for our little break. So far, we have done just getting familiar with the Cartesian plane again, understanding how it's possible to do geometry on the Cartesian plane. And then we've just started to get used to this new tool, which is almost like a ruler. It's like a measuring stick for the Cartesian plane. It gives us the distance between any 2 points. Now, after the break, we'll keep on going, but you know my philosophy about taking care of your body and making sure that you're not stiff or tired or stressed. And the way we can do that is we can just stand up for a second. So just turn on your cameras, and you can stand up with me, and let's just take some nice deep breaths. I don't want you sitting down because then your body is kind of gonna go to sleep. You want to wake up for the second half. So let's do some breathing. Just take 3 deep breaths. One more. Okay, so you're standing up, you're breathing. Now let's get nice and loose. So let's shake out your arm. So you want it completely loose, like it's pop. Okay, this one as well. You don't want any tension, like you want a piece of, like it's like a piece of string and it's just going around. Do the same with your legs. So just shake them out so that your body feels relaxed. And do whatever you want to do just to get yourself relaxed. Okay, then let's just roll our shoulders, because often we hunch forward when we're watching and we get tense. We just want to relax our shoulders and roll them. Just roll them back. Let's roll them forward. Okay. Then let's have our arms out to the side. We're just going to make small little circles, small controlled circles, nothing too wild. And you're going in one direction, and then you're going to change direction to go back. Okay. Right, give your arm another shake. Give the other arm a shake. Let's do some tricep stretches. I often find when my shoulders get tight, these really help. That. And then this. Okay. And then let's just do a little bit of a stretch from the middle here. Okay, so I hope you're feeling a lot more relaxed. Last thing we're going to do in our little top-up energy break is we're going to do jumping jacks, which is just this. And we're just going to do 10 of them, and that's just going to get our heart rate up so our body knows we're not going to sleep anytime soon. Okay, start in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 more. 12, and we're good to go. All right. Then we are just going to do a little logic puzzle. That's one of my favorite ones, actually. So we did our stretching and our breathing. So our brains are like, okay, cool, let's do this. So here's your little logic problem for today. If 7 people meet each other and each shakes hands only once with each of the others, how many handshakes have there been? And just to help you, I'm going to draw out your 7 friends or people who are involved. So there are 7 people and they only shake hands once, only shake hands with each other once. Like, you know, when you introduce yourself to someone, you're not going to do it again. How many total handshakes would there need to have been for this to happen? Now, I might not give the answer away today, but I'll give you a little bit of a guide to help you. So imagine you're the first person, and if you person number 1, you shake the person next to you, and then you're going around the room and you're all very friendly. How many handshakes does person number 1 need to make in order to shake everyone's hands? It looks to me, let's have a look at what's going on in the chat. That person number one, oh, Sange, you're on the right track. So person number one has to shake 6 other people's hands. But then that person's done. But what about person number two? Well, person number two has already shaken person number one, but you also have to shake hands with a whole bunch of other people. So that'd be 1, 2, 3. That would be 5. Okay, but now what about person number 3? Whose hands do I still have to shake? Well, I have to shake that person's hand, that person, and that person. Now that's some pretty big hits. So how many handshakes in total will there be for 7 people? Oh, you guys are getting it. Ronnie and Sange. Okay, this is quite a famous problem in mathematics, but what you can see is that there's a pattern coming here. And what you see is that the total number of handshakes is going to be 21. And because if you're 7 people in a group, the first person can only shake hands with 6 other people. And then once that's been used up, the next person only has 5 available hands, and then so on. And so this clever little pattern is what gives it. Another way of doing it sometimes is to go 7 times 6 divided by 2. But yeah, it's a very famous network problem in maths. And so I hope you enjoyed it. And I hope you, yeah. And then before we go back to the maths for tonight, I just want to do, in case some of you joined late, just to let you know that our boot camps are starting this Saturday. This week, we're going to do paper 1, which is the exponents, inequalities, algebra, simultaneous equations, quadratic equations, etc. Week 2, trig and circle geometry. And then the last week is a combo of the 2. If you want to join us, you have to register and pay by tomorrow evening at midnight, because on Wednesday morning we start sending out all the information about how it's going to work. And so if you want to sign up, the QR code here will work, or you can speak to our customer service, or you can go to our website and you'll see it on the front page. But you do need to register and pay in order for that to, in order to kind of get on board with that, if you have the time. And the reason we do this is in previous years, students have said, look, as we get close to exams, we really value even more time revising. And so that's why we offer these based on previous years' experience with students. Okay, are there any questions about that? Okay, awesome. Well, then let us get back to the maths at hand. So here is another question, but this one is a bit more detailed. So let me make it a bit bigger so you can all see what is going on. Now, it says the coordinates of a right-angled triangle ABC are A, B, and C, and as follows. What is the length of the hypotenuse of the triangle? Now, the hypotenuse is the one opposite the right angle. I'm having a bit of a problem, though, because I'm feeling a bit like, well, how do I know what side to go for? What should I do to make my life a bit easier and try and understand what's going on here with this information? How can I make it a bit more understandable? Who has some ideas for me? Calculate to find the longest side? Absolutely. So the one way of doing this would be to say, you have to find AB, BC, and AC. And then the one that's the longest would be the hypotenuse. That's one way we could do it. Any other ideas or tricks we could use to figure out which side we probably need to look at? There's probably a couple of things we can do. I have one idea that I'm going to suggest, but there might be somebody else who has an idea. So I was thinking, why don't I make a little drawing, a little sketch drawing, just to give me a feel? So 1 across, 2 up. So here is the blue, that's A. and then 3 across. 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, let's make that B. And then green, 7, 4. 1, 2, 3, 4, 5, 6, 7, 2, 3, 4. Now, if I think of those points as A, B, and C, and that's a roughly accurate sketch drawing, it becomes a bit clearer to me which side I should be going after. Which of the 3 sides should I be calculating for my hypotenuse? Based on that drawing, that little sketch drawing I did. Remember, the hypotenuse is always going to be the longest side of a right angle triangle. Yes. Well, it's going to be the one opposite the right angle, and it's always the longest side. So visually, I can now clearly see I'm after AC. I want you guys to work out what AC is and then choose the correct option in there. And the way that we would write the distance formula to help us would be like that. So find me what AC is and then choose the correct option from the choices there. Over to you guys. Okay. So what are we going to do here? So we have, make sure we choose the correct point. So maybe we should write down that A is the point 1, 2, and C is the point 7, 4. 7 minus 1, and then 4 minus 2. 7 minus 1, yep, so that's 6 squared, and that's 2 squared. Did I make a silly mistake? Let's have a look. So to me, this is the square root of 40, but now there's nothing here which is the square root of 40. But square root of 40 is a surd, and there are surd laws that allow us to break these down. And if you go back to the beginning of the year, we normally like one of them to be a perfect square. And so this would be 2 root 10 would be my distance. Sorry, everyone, my page just jumped a little bit. Is there anything for 2 root 10? Yes, there is. The correct option should be B. All right, give me a score out of 10 about how you feel about the distance formula. So 10 if you feel like you have perfect understanding, 0 if you feel like none, 5 is sort of okay, but still getting there. Maybe like an 8 is like very, very solid. Tell me how you feel about this distance formula tool. Get your votes in, people. Score out of 10, let me know. Okay, fantastic. All right, so what we're going to do now is there's a second tool that we need to learn to use, and it's called the midpoint formula. But the midpoint formula is a piece of cake. It is the most easy formula in the world. And so I'm going to show that to you now, and you will see how wonderful it is. So in addition to knowing how to find the distance between 2 points, we have to also be able to find the midpoint between 2 points, or the line segment between 2 points. So let me illustrate this for you. So if I have a Cartesian plane and I have the point minus 2, 5, so I go 1 across, then I go 1, 2, 3, 5. So here's the point minus 2, 5. And then 6, 1, or 6 minus 1 is 1, 2, 3, 4, 5, 6. There is the second point there. We'll call this A, we'll call this B. So A, and B. Now, if I want to find the midpoint between A and B, it's literally, we often call it the letter M. It's literally the point at which it's halfway if the yellow and the green are equal to each other. Another way of illustrating it would be often is like to say this side is equal to that side over there. So how do we find the midpoint? Well, it's as simple as this. We say, what is the first x coordinate? And we add it together to the second one and we divide it by 2. What is the first y coordinate? What is the second y coordinate? Divided by 2. So how does that work in this situation? Well, all I need to do is I go, the first x coordinate is -2. Then I'm going to add 6 and divide by 2. The first y coordinate is 5. I'm going to add -1, and then I'm going to divide that by 2. And that is going to give me M, my midpoint. Which of the 4 options, A, B, C, D, do you think is the correct answer? Which of these 4 options do you think is the correct answer? -2 plus 6 is 4, so 4 over 2. And then this would also be 4 over 2, which makes me think, is there a 2 over 2? No, sorry, is there a 2, 2? And there is indeed. So it's the point A, which is the point 2, 2. Visually, if I had to find it, it would be kind of over there. 2 across, 2 up. My scale drawing wasn't too bad. So the answer should be 2, 2. What could have gone wrong? Some people could have got a bit confused by this. So -2 plus 6 is +4. So watch out for that. 5 plus -1 is also +4. And so watch out for that. All right, let's do another one. Please find me the midpoint of these 2 coordinates. So what is the midpoint between these 2 coordinates? So tell me the answer in the chat with A, B, C, or D. So if I think about the formula, I should just have a big divided by 2 and a big divided by 2 on this side. And then we would say -2 plus 3, and then 9 plus -2. So what is that going to give me? It's going to give me 1 over 2, and then it's going to give me 7 over 2, it appears. So who can spot the correct answer here? There's lots of halves. It can't be this one and it can't be that one. So it's either that or that. But 7 over 2 is the same as 3.5. And so the correct answer must be C. Okay, well, I think you guys are getting that. So let's do another one. Let's do one where there's more of a picture involved. So find me the midpoint of AB, where A and B are on the drawing here. And then you need to vote. Find the midpoint of AB. So A is that, B is that. What is going to be the midpoint? Often we write it like this, the midpoint, then we say it's to do with the line segment AB. So -5 plus 7 over 2 would be the x part, and then 2 plus 7 over 2 would be the y part. So which answer do we think is correct? So for me, that would be 1, 4.5, which is, oh, another C. So that would be C. And if I'm looking at the chat, Ronnie agrees, Siamtanda, Sange agrees, Stephen agrees. So I think we're all good. So it feels like, give me a score out of 10 for your mastery of the midpoint formula. Like 0 is nothing, 10 is perfect, 5 is like sort of okay, but still improving. Give me the score there out of 10 for your, okay. I think the midpoint formula is a bit easier, yeah. Okay, well, let's go and find a couple more interesting questions with the last 5-10 minutes we have left. Find me both the midpoint. So I want to know the midpoint of PQ, and I also want to know the distance between P and Q. So here's P and Q. You need to find me the midpoint between P and Q and the distance between P and Q. Oh, absolutely, Mussolini. So there's a couple of places that you can get the recordings. The probably the easiest place, well, there's two ones, okay. You can go straight to our YouTube channel and look at the playlist for 11S. The recordings will be there. Or if you go into Google Classroom and you click on the admin, under classwork, under admin, you will see a link, a direct link to our 11S playlist. So in Google Classroom, under the admin classwork, there's a link to our YouTube channel. And all our lessons are recorded. They're normally up within the next day based on what I've seen. So I hope that helps, Mussolini. So what is my midpoint of PQ going to be? Let's do that one first. What is my midpoint of PQ going to be? So for me, this is -4, 2, and then this is 0 over 2. So what does that give us if we simplify it? It's going to be -2, 0. Yeah. So it's kind of literally on the x-axis. If you were to imagine like, where's minus 2, 0? It's on the x-axis. So that's where the midpoint is. So the other 2 points must be on either side. Okay, what about the distance between P and Q? We have to be a bit careful here because there's lots of minuses involved. What do you get for the distance between P and Q? So we've got our midpoint already. So that was, the midpoint was minus 2, 0. But we want to get the distance between P and Q. And I said -1, -3, and -5, -5. Now, -3 is +3. So this is actually 2 squared. And then this is going to be plus -10 squared. And then this is going to be 4, and this is going to be 100. So this is going to be the square root of 104, or just over 10, basically, like 10 point something. I think Stephen is saying 10.19, Sange 10.2. So it's approximately 10.2 in units. All right. So everyone, I'm going to call it quits for tonight. I think we've done a good job. So let's just reflect on what we learned. We learned about the distance formula, and I'll write it down one more time so that it is clear to you. What it looks like is it's got these 2 parts with squares, which we borrowed from Pythagoras. And then we had the difference in x and the difference in y. And then the midpoint formula was just wonderfully easy. It was just x1 plus x2 divided by 2 and y1 plus y2 divided by 2. We also spoke about this thing called the Cartesian plane and how it has quadrants and how it has coordinates, and being able to identify where coordinates are. In the next lesson, we're going to start to talk about straight lines and how we describe straight lines with formulas, and also how we speak about the gradient of straight lines and things like that. And that is it for tonight. So I hope you enjoyed the lesson. Please make sure to speak to your parents. If you intend coming to boot camp, the deadline is tomorrow evening for payment, or tomorrow at midnight. And also, please, if you haven't done your quizzes, go and do your quizzes for previous weeks if you have any extra time.